In the silence between stars, something impossible is unfolding. Far beyond the orbit of Mars, a visitor from another system drifts through the void, silent, steady, and unblinking. It came from the deep dark between suns, a region where even starlight fades into nothing. For months, astronomers have tracked its path, a ghostly fragment of another world crossing through our solar system. They called it 3I/ATLAS. At first, it was thought to be a comet, another frozen relic from the birth of a distant sun, but in the vast stillness of space, 3I/ATLAS has begun to change. In a single week, it doubled in size, not over centuries, not through impact or accretion, but in 7 days. From a modest 23 kilometers across to 46, its surface area expanding, its shadow growing. And the laws of physics, the laws that bind every particle, every planet, every sun, have no words for what is happening. The cosmos is governed by principles older than life itself. Matter does not appear out of nothing. Solids do not expand without force. Ice does not grow larger under heat. Yet here, before our instruments and eyes, an object from beyond our solar system has done exactly that. The universe has offered us a paradox, one that challenges every equation we've trusted to describe it. Before this anomaly, comets were thought to be predictable things, frozen remnants from the dawn of planetary systems, their journeys long, their fates familiar. As they neared the warmth of a star, the ices within them would sublimate, vaporizing into clouds of gas and dust that scatter sunlight into a radiant tail. The coma, a glowing envelope, might stretch for millions of kilometers, but it was always ephemeral, made of emptiness and light. The solid nucleus at the heart of the comet, the true body, never grew larger. If anything, it eroded, shrinking as its frozen core evaporated into the solar wind. That was the rule. But 3I/ATLAS has ignored those rules. Between October 12th and 19th of 2025, telescopes across Earth recorded the unthinkable. The European Southern Observatory's Very Large Telescope in Chile, NASA's infrared facility in Hawaii, and the Gemini Observatory each turned their instruments toward the visitor. The data aligned perfectly, images across multiple wavelengths confirming the same result. On October 12th, the object measured 23 kilometers across. 7 days later, 46. Not a difference of precision, not an illusion of brightness, a literal doubling in size. If the object were solid, such an increase would mean an addition of over 500,000 cubic kilometers of material. For comparison, that's 7 times the volume of Lake Superior, appearing in space out of nothing. No known natural process can account for that. The physics simply doesn't allow it. For a moment, astronomers searched for comfort in error. Perhaps it was measurement bias, a trick of angle or instrumentation. But the data was clean, independent, verified. Something real had occurred. And so, the conversation shifted from natural to impossible, from ice and rock to structure and intent. Avi Loeb, the Harvard astrophysicist who once proposed that Oumuamua, the first known interstellar object, might be artificial, returned to the discussion. His earlier suggestion of hollow architecture now seemed prophetic. If 3I/ATLAS were hollow, then expansion might not represent growth at all, but transformation. Imagine a vessel built for the stars, a structure designed to cross interstellar distances, compacted for travel, minimizing exposure to micrometeoroid impacts, conserving energy across millennia of flight. As it nears a target system, it deploys, expanding its framework, unfolding panels, revealing instruments and arrays meant for observation or communication. To some, this may sound like science fiction, but to engineers it sounds like logic. Yet the mystery deepened further when Dr. Sarah Chen of the Kayak Observatory published her preliminary report on October 20th. The expansion, she noted, was asymmetric. The northern hemisphere of 3I/ATLAS grew faster than the southern. Solar heating, if responsible, should have produced uniform sublimation, not such uneven growth. The data suggested localized movement, sections of structure shifting independently as if following a sequence. Amateur astronomers soon corroborated what the institutions hesitated to confirm. From Germany, Marcus Reinhardt captured a time-lapse series across several nights showing distinct phases of expansion. Between October 12th and 15th, almost nothing. Then, rapid growth between the 15th and 17th concentrated in one region. By the 19th, it stabilized, motionless once more. A natural process would be smooth, continuous, random. This was discrete, timed, as if governed by internal mechanics. And then came the flashes. At 3:47 UTC on October 16th, amateur astronomer Jennifer Park in South Korea recorded a brief burst of light, a sharp spike lasting just over 4 seconds. The brightness intensified, then faded, returning to baseline. 6 hours later, observers in Chile and Australia captured identical events. Not noise, not cosmic rays. The same object, flashing at the same intervals, across hemispheres. A signal, perhaps? Or the ignition of something mechanical? Energy being redirected, mechanisms unfolding, power systems coming online? These are not ideas scientists offer lightly. To entertain the possibility that a structure is moving under its own control demands abandoning centuries of natural assumption. But the data leaves little comfort for conventional thought. 3 explanations have emerged, each stretching the fabric of known science to its limits. The first, extraordinary outgassing. Perhaps the object contains ices of a type unknown, volatile compounds that erupt violently when heated, producing a coma so dense it appears solid. But spectroscopy from the James Webb Space Telescope contradicts this. The observed chemical signatures remain ordinary. Carbon dioxide, water ice, silicates, nothing exotic. And the albedo, the reflectivity of the expanded surface, is consistent with dense structured material, not a diffuse gas cloud. The second, internal pressure release. Maybe gases trapped within the hollow interior expanded under solar heat, forcing the shell outward like an inflating balloon. Plausible, perhaps, until you consider 2 details. First, the expansion stopped, precisely, at 46 kilometers and has remained constant. If pressure were the cause, expansion would continue as the object approaches the Sun. It has not. Second, a pressure failure of that magnitude would tear a comet apart, scattering fragments across space. No such debris has been observed. The third explanation defies our comfort entirely. Controlled deployment, a mechanism unfolding by design, sections of a larger structure reconfiguring in stages, internal systems activating to extend panels, modules, or instrumentation. Not chaotic, not random, deliberate. The timing is chillingly perfect. 10 days before perihelion, the point in its orbit closest to the Sun. The exact window when structural reconfiguration would need to be completed to withstand or utilize the solar radiation to come. This is not speculation for its own sake. Human engineers have already designed spacecraft that behave this way. The James Webb Telescope unfurled its golden mirrors and vast sunshield through hundreds of synchronized mechanical operations. The Kepler telescope deployed its light shield. Even small CubeSats carry solar panels that fold and unfold. Every movement deliberate, every stage monitored. If humanity builds such machines to cross planetary space, would an interstellar civilization not do the same on a grander, older scale? The implication chills the air of every observatory on Earth. If 3I/ATLAS truly reconfigured itself, then humanity is not observing a comet. It is witnessing technology, alien, silent, and operating according to logic we barely comprehend. The energy required alone would be staggering. To move massive structures at 200,000 kilometers per hour with precision without fragmentation implies immense internal power reserves and control systems. No random thermal process can do that. The data suggests a hand or perhaps a mind behind the motion. But science is patient. It resists conclusions born of wonder. NASA's Jet Propulsion Laboratory issued only a brief statement on October 21st, acknowledging the anomalous measurements and confirming that analysis was ongoing. The European Space Agency released images but offered no interpretation beyond those cautious words, silence. And that silence says everything. When the evidence defies explanation, institutions pause. History remembers too many false dawns: cold fusion, faster than light neutrinos, Martian fossils that prove to be dust. Scientists fear premature revelation more than obscurity, but there is a threshold where anomaly becomes evidence, and 3I/ATLAS may have crossed it. This is not an isolated peculiarity. It's part of a pattern that has been building for years, a cosmic escalation beginning in 2017 with Oumuamua. That first interstellar visitor accelerated slightly as it left the solar system in defiance of gravitational models. Its motion could be attributed, barely, to radiation pressure. It was strange but survivable within known physics. 2 years later, Borisov arrived, a more typical comet, as if the universe were reassuring us that the first had been a fluke. But 3I/ATLAS is no reassurance. It is rebellion. Unlike its predecessors, it decelerated when it should have sped up. It maintained rotation stability when random torque should have made it tumble. Its density suggested a hollow interior. Its flybys of Earth and Mars aligned with precision so unlikely, the odds against coincidence exceeded 50,000 to 1, and now it has grown, doubled in size, without losing structure. Each behavior on its own might be dismissed as coincidence. Together, they form a constellation of impossibility, 6 major anomalies, each improbable, occurring in sequence. Probability collapses under their combined weight. It is as though the universe itself is telling us something, or perhaps showing us something. In the night sky, 3I/ATLAS glows faintly now, a dim ember against the infinite black. But to those who have measured its pulse, its rhythm, its impossible change, it has become something more than a comet. It has become a mirror, reflecting the limits of our understanding back at us. In 3 days, it will reach perihelion, its closest point to the Sun. That moment will decide everything. If it fragments, we may retreat to the comfort of nature, declaring it a rare and fragile object undone by heat. If it remains stable, the anomaly deepens. But if it changes again, if another expansion, contraction, or structural shift occurs, then every model of cosmic behavior collapses. For then, we would not be observing nature, we would be witnessing intention. Already, speculation blooms among scientists who once avoided the word artificial. A larger configuration could function as a solar sail, using photon pressure to alter trajectory with precision. It could act as an antenna, drawing power from solar radiation to transmit or receive, or it could serve as a platform, a mother structure preparing to release smaller craft, dispersing like seeds into the solar wind. The dandelion seed hypothesis, once theoretical, suddenly feels hauntingly plausible. The expansion might not be an end but a beginning, an opening of doors. And if those doors open fully during perihelion, when the object passes behind the Sun, it would do so unseen. Our instruments, blinded by the solar glare, would lose sight of it for weeks. Whatever happens in that hidden interval will unfold beyond our gaze. When it emerges again in December, it may no longer be the same object at all. The Galileo project, led by Avi Loeb, has prepared instruments to monitor every possible development: optical, radio, electromagnetic. They will search for evidence of smaller bodies, for structured motion, for transmissions that break the silence of the cosmic background. If such signatures appear, it would mean the question humanity has whispered for millennia has already been answered. Are we alone? Perhaps we never were. The data whispers of a presence, an object from beyond our star's birth, moving with purpose through our domain, reshaping itself in full view of our telescopes. A silent envoy from elsewhere, acting according to its own unknown logic. If that is true, then the moment we are living through, These days of quiet observation and disbelief may one day be remembered as the instant when human history divided in two, before and after first contact. But contact may not come with sound or light or message. It may come with a shadow in the sky that grows larger without reason, a whisper of movement in the darkness that refuses to obey physics, a visitor that doubles in size as though inhaling the energy of the sun itself. Perhaps this is how civilizations meet, not through greetings or war, but through questions that rewrite the laws of nature. And perhaps the cosmos, in its own mysterious language, is speaking to us now. Through the silence of the universe, the echoes of human curiosity continue to expand, an echo as vast as space itself. The comet known as 3I/ATLAS, the interstellar messenger that once passed quietly through our solar system, has now re-emerged in cosmic data, growing not just brighter, but larger, more complex, and infinitely more mysterious. What once seemed like a simple block of ice and dust has defied the expected decay of cosmic travelers. Instead, it's expanding, it's evolving, and it's rewriting what science thought it knew about the forces shaping the dark corridors between the stars. The anomaly began subtly. Observatories tracking the comet's infrared emissions noticed an inexplicable doubling in its thermal profile, a signature that implied a body far larger than its initial estimates. But how could something drifting through the frigid emptiness of interstellar space, bombarded by cosmic radiation, grow in size? The vacuum should strip, not build, evaporate, not expand. Every known physical law whispered the same answer. It shouldn't be possible, but the data persisted. When NASA's Deep Space Network cross-referenced signals from the Atlas survey, the readings were verified. The mass reflection was real. The comet's envelope, composed of molecular hydrogen and complex organics, was amplifying, not dispersing, as if feeding on invisible matter. Something unknown was interacting with it, sustaining it, changing it. And so began a new phase of cosmic investigation, one that stretched the limits of both astrophysics and imagination. Some scientists proposed a radical explanation, that 3I/ATLAS may be surrounded by a sheath of dark hydrogen, a form of matter that exists only at temperatures near absolute zero. In the depths of interstellar space, this rare form of hydrogen might act like an invisible cocoon, capturing cosmic dust, building a crust from the faintest remnants of the universe's earliest particles. If true, it would mean comets like Atlas are not just wanderers, but cosmic archives, silent carriers of pre-galactic material, drifting relics from the dawn of existence. Others took the theory further. What if ATLAS had interacted with a dark matter field, an unseen halo enveloping our galaxy? Dark matter doesn't emit or absorb light, but it shapes the fabric of reality through gravity. A passing comet might distort that field or even accumulate particles through quantum friction, a process still hypothetical but not impossible. If Atlas was somehow gathering dark matter, its mass increase could be a glimpse into one of the universe's greatest mysteries, matter that makes up 85% of everything yet remains invisible. As the observations deepened, so did the enigma. Its trajectory began to shift, subtly, as if tugged by unseen hands, not enough to suggest alien intervention or propulsion, but enough to challenge gravitational models. Some researchers quietly noted the possibility of internal outgassing, volatile materials within ATLAS heating unevenly, generating microthrusts. Yet even that couldn't fully explain the scale of its change. The comet's luminosity and thermal signature both doubled, meaning not just motion, but transformation. Perhaps the most haunting theory came from an unexpected source, a physicist studying cosmic strings, theoretical one-dimensional fractures in space-time itself. If Atlas had passed near one of these filaments, even momentarily, it might have absorbed exotic energy or particles unknown to current physics. It could have become, in effect, a cosmic experiment, a body imprinted with the scars of the universe's earliest moments. But the universe guards its secrets well, As the data flowed, the silence between signals deepened. Astronomers began to notice faint electromagnetic pulses in Atlas's spectral signature, repeating at intervals, faint but structured. Some thought it was a measurement error. Others whispered of patterns, the kind nature rarely creates without reason. Could it be an echo of the comet's interaction with interstellar plasma, a resonance between magnetic fields across light years of emptiness, or something older, something woven into the physics of creation itself? The investigation drew parallels with another cosmic visitor, Oumuamua, the first interstellar object ever detected in 2017. Like Atlas, Oumuamua defied expectations. It accelerated as it left the solar system, spinning irregularly, shining in ways that suggested more than just rock and ice. For years the debate raged, natural phenomenon or something engineered. Atlas's growth now reopened that debate, adding a new layer of intrigue. What if interstellar objects aren't anomalies at all, but part of a cosmic ecosystem we've only just begun to glimpse? Through the telescopic eye, ATLAS appeared serene, a glowing thread moving across the black tapestry of space. Yet beneath that calm, a silent storm brewed. The laws of physics seemed to bend around it, not break, but flex, as if revealing hidden variables we've never known to look for. The universe was hinting at something, offering a glimpse of a deeper framework, one we can sense but not yet describe. As scientists continued to model the data, philosophical questions emerged, not from curiosity, but necessity. What if growth, decay, and transformation are not bound solely to biological life, but to the universe itself? What if every atom, every comet, every drifting piece of dust is part of a grand process of cosmic evolution, one that doesn't stop at stars and galaxies but extends to all matter? If Atlas is growing, perhaps it's not defying nature, perhaps it's obeying a higher order of it, a kind of universal metabolism, where energy is never still, where entropy breathes in cycles of expansion and renewal. The cosmos, after all, has never been static. It expands, it evolves, it remembers. NASA's teams remain cautious, tethered to data and mathematics. But somewhere beyond the silence of deep space, ATLAS continues its quiet metamorphosis, drifting through starlight like a thought too vast for words. Its glow, brighter than logic predicts, stands as a beacon to the limits of understanding. And so the story continues. Each new scan, each spectral analysis adds a layer to the mystery, like decoding a message written not in words, but in physics. The comet's growing halo now stretches wider than before, reflecting a strange bluish light, the kind emitted when cosmic rays strike organic compounds. Could it be that ATLAS is awakening chemical reactions deep within its frozen core, reactions that may once have seeded the first molecules of life across galaxies? If so, then Atlas is not merely growing, it's echoing creation, a fragment of the cosmic nursery, still alive, still weaving the patterns of existence into the void. It is easy to forget, in the face of data and uncertainty, that the universe does not owe humanity clarity. It reveals itself in whispers, in shifting lights, in the faint hum of particles dancing at the edge of comprehension. 3. I/ATLAS, in all its silence, may be one of those whispers. A quiet voice reminding that discovery is not about finding answers, but learning to ask better questions. Perhaps in time, new telescopes and deeper sensors will decode its secrets, the quantum forces shaping its growth, the invisible fields guiding its path. But until then, it remains what it has always been, a messenger from beyond the stars, carrying a truth too vast for one species to fully grasp. And somewhere in that truth lies the reflection of our own search for meaning. For in observing Atlas, humanity is not just watching a comet grow, it's watching the boundaries of knowledge stretch and expand, just like the universe itself. Because perhaps the universe is not a place we live in. It is something alive, something that learns, remembers, and evolves. And through Atlas, we are catching a glimpse of that eternal process still unfolding in the silence between stars. So the question lingers, what if this growth is not an anomaly, but a sign a sign that matter, energy, and consciousness are more intertwined than we dare to imagine. What if Atlas, in its expansion, is echoing the very heartbeat of the cosmos, the same pulse that drives galaxies to spin, stars to ignite, and life to wonder where it all began? Perhaps one day humanity will find the answer, or perhaps as the light of ATLAS fades into the infinite dark, the question itself will be the answer, a reminder that even in a universe governed by physics, there remains room for wonder. Because in the end, every mystery is a mirror, and through Atlas, the universe is holding one up, not to show how small we are, but how infinite the human desire to understand can truly be. And as that glowing comet drifts farther into the unknown, it carries not just dust and ice, but the reflection of our own curiosity, a spark that, like the stars themselves, refuses to die. For perhaps the greatest truth of all is this, that the cosmos does not simply exist, it grows, just as we do, just as ATLAS has, just as every idea that ever dared to look up and ask, what if? In that question lies the heartbeat of creation, and in that silence, the universe listens.